Hello friends, myself R.D. Mahajan presenting my video on the topic half range Fourier sine series. Let us solve the problem. Find half range sine series for the function f of x is equals to there are two values. First one 1 range 0 less than x less than 1, and second value is x for range 1 less than x less than 2. Therefore, the total range is 0 to 2, 0 to L type. Therefore, comparing, we get value of L as 2. Comparing 0 to L with 0 to 2, we get value of L as 2. And as we require to find half range sine series, we have value of A0 as 0, value of An is also 0 in that half range sine series, and only we require to find Bn by the formula 2 by L integration from 0 to L f of x into sine of n pi x by L, and its integration with respect to x. Substituting the values, the value of L is 2, therefore 2 by 2, integration from 0 to 2. 0 to 2 is not a continuous range, we are having two different values, therefore we keep that fx as it is here, or we are not able to substitute value of f of x into sine of n pi x by 2 and its integration with respect to x. And in next step we split it as per this range, therefore that integral become integration from 0 to 1. Function value is 1, therefore 1 into sine of n pi x by 2 and its integration with respect to x, plus another integration from 1 to 2 where the function value is x, fx is x, multiplied by sine of n pi x by 2, and therefore we have two separate integrals. Therefore first one we call as I1 and second one as I2, and we call this equation 1, where that value of I1 is, it is integration from 0 to 1 of sine of n pi x by 2 and its integration with respect to x. Performing the integration of sine is minus cos of n pi x by 2 divided by coefficient of x. Coefficient of x here n pi by 2 and limits from 0 to 1. Substituting the upper and lower limit, we get the value of I1 as 2 by n pi, 1 upon n pi by 2 means it becomes 2 by n pi. I will cancel its minus sign by changing the limit. For upper it becomes 0, cos 0 is 1, minus for lower limit when we put x as 1, that term becomes cos of n pi by 2. And as we don't have any standard value for that cos of n pi by 2, we keep that term as it is, and therefore we call this is equation number 2. I2 is integration from 1 to 2 of x sine n pi x by 2, and as it is product of two terms of x, we have to apply UV rule, integrating it by generalized part. X as it is trigonometric first, and x as algebraic, therefore it is first function, and sine as trigonometric, therefore we consider this as second term or second function. And then integrating it by generalized part, we get first term as it is. Integration of sign. Integration of sign is minus cos of n pi x by 2 divided by coefficient of x. Coefficient of x is here n pi by 2. Okay. Then minus derivative of x. Derivative of x is 1 with respect to x. Its next integration. Next integration of cos is sine with this minus sign. Therefore it is minus sine n pi x by 2 divided by n square pi square by 2 square. We get 4. Next derivative 0, we stop here and limits are from 1 to 2. We get when we put the upper limit as 2, here it is 2 times 1 upon n pi by 2 means it becomes 2 by n pi with minus sign, therefore minus. When x is 2 to get cancelled, we get cos n pi, and the value of cos n pi is minus 1 raised to n. Minus minus it becomes plus. Here it becomes sine of n pi, and the value of sine n pi is 0. These are the two values for upper limit minus lower limit. X is 1, therefore it becomes minus 2 by n pi. When x is 1, it becomes cos of n pi by 2. And this becomes plus 4 upon n square pi square. 4 upon n square pi square. X has 1 means this term becomes sine of n pi by 2. This is minus minus plus, therefore it is 2 by n pi cos n pi by 2. Then minus 4 times sin n pi by 2 divided by n square pi square, and this one is minus 4 minus 1 raised to n divided by n pi as value of I2. We call this equation number 3. And then substituting that two values of I1 and I2 in equation 1, we get therefore I1. Substituting value of I1 and I2, the value of I1 is 2 by n pi, 1 minus cos n pi by 2, and value of I2 is, there are 3 terms in I2, 2 divided by n pi cos n pi by 2 minus 4 sin n pi by 2 divided by n square pi square, and minus 4 times minus 1 raised to n upon n pi. And if we simplify it, we get this one with minus sign and this is with plus sign. Opposite sign term cancel each other. We have the term remaining terms as first one 2 divided by n pi, then minus 4 times minus 1 raised to n divided by n pi, and minus 4 sin n pi by 2 divided by n square pi square. Equation number 4th. A final value of Bn, and then substituting this value in that Fourier series result we get. Then Fourier series is given by that half range Fourier series a0 by 2 summation of an cos n pi x by l, n changes from 1 to infinity, summation of bn sin n pi x by L, n changes from 1 to infinity. Here value of a0 is 0, value of n is also 0, value of bn is 2 divided by n pi minus 4 times minus 1 raised to n divided by n pi minus 4 sin n pi by 2 divided by n square pi square, value of bn, and that is multiplied by sin n pi x by L, value of L is 2. Therefore, that term becomes sin n pi x by 2, and n changes from 1 to infinity, and therefore final result is summation from 1 to infinity two by n pi minus 4 minus 1 raised to n divided by n pi minus 4 times sin n pi by 2 divided by n square pi square into sin of n pi x by 2 as the required for a series for that function fx having two values. This is the required half-range Fourier sine series. One more I will discuss in my next video on. If you are watching my videos, please like and share it, as well as subscribe to my channel to get new updates on new videos. Thank you. Thank you.